Welcome back. Right, so let's look at this problem here. We're going to be using the sandwich rule, but it makes sense, sandwich theorem. It makes sense for us to simplify this first. All right, so notice we only have one term in the divisor. Let's divide each term by x. So we have the limit as x approaches infinity of 5x divided by x plus sine x divided by x. Remember from our properties that the limit of a sum equals the sum of the limits. Right? So I can split this into two limits. The limit as x approaches infinity of 5x divided by x plus the limit as x approaches infinity of sine x divided by x. All right, so now let's calculate each limit separately and combine them together for the final limit. Let's reduce 5x divided by x. All right, so the x's will cancel. This is the limit of 5 as x approaches infinity. Well, this is a horizontal line. The limit of 5 as x approaches anything is 5. All right, so you have the limit of a constant. It doesn't matter what it's approaching. It's that constant. All right, so that one's done. Let's use the squeeze theorem to find this one. All right, so just like we did before, all right, we're going to just look at the sine x part. So we know, so here we're going to calculate the limit for sine x. We know that sine is stuck, right, between -1 and 1. Right? It just oscillates between those two. The least it ever is -1. The most it ever is 1. Let's just divide everybody by x. Right? So likewise, -1 divided by x will be less than or equal to sine x divided by x, less than or equal to 1 divided by x. All right, so now let's find the limit of, as x approaches infinity, of -1 over x. Well, we know -1's a constant, right? And so when we have a constant divided by something that's growing without bounds, that's a 0. And it really doesn't matter what that constant is. A constant divided by something that's growing without bounds is going to be 0. Right? So since -1 divided by x is less than or equal to sine x divided by x is less than or equal to 1 over x, and the limit as x approaches infinity of -1 over x is equal to the limit as x approaches infinity of 1 over x, then by the sandwich rule or sandwich theorem or squeeze theorem, whichever you prefer, I'm going to abbreviate theorem, the limit as x approaches, that's an arrow. That really does not look very arrow-like. X approach, oops, I forgot to write the limit in now. Try that one more time. The limit as x approaches infinity, I'll take that as an arrow. That's good enough. How's that? Sine x over x equals 0, 2. All right, so you're always going to make sure you justify. Sometimes I label my functions with fx, gx, and hx, f of x, g of x, and h of x, so then I don't have to write the functions again. But because these were really short, I didn't really bother to do that. So now we know that one's 0, and we just have our work right over there, right? So our limit as x approaches infinity of 5x plus sine x divided by x ended up being 5 plus 0, or just 5. right? And that's all there was to this one, all right? So this isn't any particular, anything special. I'm teaching you about the limit of, as x approaches infinity, of 5x plus sine x over x, but rather how to use squeeze theorem, sandwich theorem, to find the limit of an indeterminate limit that is bound, like sine x divided by x is, and use that in this particular problem here. All right, so thanks for watching. Bye for now.